You're lying in bed at 2 a.m., not thinking about something new, thinking about the same thing you thought about at dinner and before dinner and on the drive home. Maybe it's money. Maybe it's a relationship that's gone sideways. Maybe it's something a doctor mentioned that was probably nothing, and you've been stuck on that probably ever since. Here's what nobody tells you. The harder you stare at the problem, the more frozen it becomes. Not as a mindset tip, not as self-help advice. I mean at a physical, measurable, documented in physics level. Your attention is locking the thing you're watching in place. In 1977, two physicists at the University of Texas at Austin, named Baidyanath Misra and E.C.G. Sudarshan, published a paper in the Journal of Mathematical Physics. They called it the Zeno's paradox in quantum theory. Their finding: if you observe a quantum system frequently enough, it cannot transition to a new state. The act of watching freezes it. 13 years later, a team at the National Institute of Standards and Technology proved it in a controlled lab experiment with real particles. The watched pot never boils. That stopped being a folk saying in 1990. It became physics. But here's what keeps pulling at me. 3 completely separate ancient traditions figured this out centuries before we had particle traps or lasers. They had no equations. What they had was thousands of years of running the experiment on human consciousness, and every single one of them came back with the same result. First, let's look at what actually happened in that lab. David Wineland and his team at NIST in Boulder, Colorado, trapped approximately 5,000 beryllium-9 ions in an electromagnetic field. Left alone, those ions would naturally shift from one energy state to another over exactly 256 milliseconds. Predictable, reliable. That's what the physics was supposed to do. Then they started measuring it. They fired short laser pulses at the ions during the transition, which functioned as measurements. Each pulse forced the ions to declare a state, collapsing the quantum superposition. Here's what happened. With 2 measurement pulses, 50% of the ions failed to make the transition. With 8 pulses, only 19% made it. With 64 pulses over the full 256 milliseconds, fewer than 1% crossed over. The more they watched, the more the system stayed exactly where it started. Wayne Itano, who conducted the experiment alongside Wineland, published the results in Physical Review A in 1990. The paper has been cited hundreds of times and remains one of the most referenced demonstrations of a quantum measurement effect in all of physics. The technical name is the Quantum Zeno Effect, named after the Greek philosopher Zeno of Elea. Zeno argued in the 5th century BCE that a moving arrow is stationary at every instant you observe it. Motion is an illusion constructed from frozen frames. Misra and Sudarshan looked at that old paradox and said, in quantum mechanics, it's not a paradox. It is literally what happens. Now, if that were the end of the story, it would just be a strange fact about subatomic particles. But in 2000, 2 physicists at the Weizmann Institute of Science in Israel published a paper in Nature that described the inverse. E.C.G. Kofman and G. Kurizki showed that in certain systems, reducing the frequency of measurement can accelerate the rate of change. Fewer observations, faster transition. They called it the anti-Zeno effect. I want to sit with that for a moment, because it is the entire point of this video. Frequent observation locks the current state in place. Reduced observation in the right conditions allows transition. Now the obvious question: does this principle apply to a human brain? Does it apply to the habit of obsessively monitoring an unwanted condition, whether that's debt, a health scare, a stalled decision? One psychiatrist at UCLA ran a version of this experiment on humans. He has the PET scans to prove it. Jeffrey Schwartz is a research psychiatrist at the UCLA Department of Psychiatry. In the late 1980s and 1990s, He worked with patients who had obsessive-compulsive disorder. Every patient shared the same structural pattern. They were locked in compulsive monitoring loops, checking the stove, checking the lock, washing their hands repeatedly, counting the same objects over and over. The behavior was not psychological weakness. It was driven by a specific, measurable neural circuit. Schwartz and his colleagues used PET scans, which measure glucose metabolism inside the brain, to observe what was happening during an OCD episode. What they found was a worry circuit stuck in the on position. The orbital frontal cortex, the brain's error detection system, kept firing one signal: something is wrong. And the caudate nucleus, a structure that normally functions as the gear shift between thoughts and behaviors, was jammed. It could not shift out of the error state. The result? Error signal fires, caudate jams, person checks, signal fires again, person checks again. The loop ran on its own power. Schwartz published his findings and developed what he called the four-step method, documented in his 1996 book, Brain Lock, published by HarperCollins: relabel, reattribute, refocus, revalue. The step that matters most here is refocus. Refocus does not ask the patient to stop the anxious thought. It does not ask them to fight the urge. It asks them to redirect attention to something else, anything else, for a defined period of time, to deliberately reduce the frequency of attentional contact with the problem. The PET scans showed what happened. After 8 to 12 weeks of weekly sessions practicing this method, the caudate nucleus cooled. The orbital frontal cortex quieted. The glucose metabolism in the worry circuit decreased measurably on the scans. By reducing the frequency of obsessive observation, the system was allowed to shift. That is the anti-Zeno effect inside a human skull. One important note: Schwartz's research was specifically conducted on OCD patients, a clinical condition, but the neural mechanism he identified, a worry circuit that locks under hyperattention and cools when attention is redirected, is not exclusive to clinical OCD. The evidence suggests that sustained, obsessive monitoring of any unwanted condition engages a version of this same loop. The clinical extreme makes the mechanism visible. The everyday version runs on the same hardware. If this is true, then the ancient traditions that taught non-attachment to outcomes were not practicing religion. They were practicing applied physics. The Bhagavad Gita was composed somewhere between 400 and 200 BCE, attributed to the sage Vyasa. It's a dialogue between the warrior Arjuna and Krishna on a battlefield before a war that Arjuna cannot bring himself to begin. Chapter 2, verse 47. Karmanya vadikarastema phaleshu kadachana. You have a right to perform your duties, but you are not entitled to the fruits of your actions. This verse is, by search volume, the most referenced verse in the entire Gita. It has been discussed as a spiritual and ethical teaching for 2,400 years, and it is. But read it differently for a moment. Read it as a measurement instruction. Act fully, engage completely, then withdraw obsessive monitoring of the outcome. Do not continuously measure the result of what you've set in motion. Do not watch the system after you've acted on it, because as Kofman and Kurizki formalized in Nature in 2000, watching it locks it. Now move forward about 1,700 years. Germany, 14th century. A Dominican theologian named Meister Eckhart, born 1260, died 1328, is writing and preaching about a concept he calls Gelassenheit. The word is German. It carries meanings like releasement, letting be, surrender of grip on outcomes. The Stanford Encyclopedia of Philosophy describes it as releasing willful, obsessive attachment to results. Heidegger later adopted the same word and explicitly credited Eckhart as its source. What Eckhart taught: straining, forcing, and obsessively checking whether your actions are producing results is precisely what prevents results. Full engagement, then complete release of grip on what follows. No particle physics, no PET scanner, no Weizmann Institute. Same conclusion. Further back, China, between the 6th and 4th centuries BCE. The Tao Te Ching, attributed to Laozi, introduces Wu Wei, often translated as non-action, but that translation misleads. Wu Wei is not passivity. It is acting without compulsive interference with the natural flow of what you've set in motion. The Taoist sage plants the seed, then walks away, not because the outcome doesn't matter, because continuous anxious monitoring is the specific thing that disrupts the process. 3 texts, 3 continents, no contact with each other. The Bhagavad Gita from northern India, Meister Eckhart from the Rhineland of Germany, the Tao Te Ching from ancient China. All 3 arrived at the same instruction: stop watching. Here is what I think was actually going on with these traditions, that they were empirical, literally. They used contemplative practice as a laboratory, enormous sample sizes, generations of practitioners, centuries of iteration, and they published their findings not in journals but in texts that survived because the results held up. What they kept finding, obsessive attention on an unwanted outcome stabilizes that outcome. Deliberate withdrawal of attention allows the system to shift. That is the anti-Zeno effect, described independently by 3 civilizations who never spoke to each other. William James, who wrote The Principles of Psychology at Harvard in 1890, understood the power of directed attention when he observed, "The faculty of voluntarily bringing back a wandering attention over and over again is the very root of judgment, character, and will." He meant it as a discipline of focus. The inverse is equally true. Voluntarily releasing obsessive attention from a fixed target requires the same discipline. The ancient traditions built entire practices around developing exactly that. Here is what this looks like in real life. Think about the last time you sent something important. A job application, a proposal, an apology you'd been putting off for weeks. Then spent the next 24 hours checking your phone every 11 minutes. The refresh, the recheck, the mental calculation of whether enough time had passed, the check again, and the situation didn't move. It felt suspended. Now think about a time you sent something important and then got genuinely absorbed into something else. A project that needed all of you. A conversation that pulled your full attention for hours. When you came back, something had shifted. A response arrived. Clarity landed. The thing moved. That is not coincidence. The system transitioned because the measurement frequency dropped. What Misra and Sudarshan proved in 1977, Itano and Wineland confirmed in 1990. What Kofman and Kurizki formalized in 2000 is what Schwartz was producing in his patients' PET scans with the refocus step, and what Eckhart called Gelassenheit, what the Gita called non-attachment to the fruits, what Laozi called Wu Wei, are all behavioral protocols for reducing measurement frequency on a system you want to move. Every time you obsessively check the bank account, you are locking the bank account. Every time you refresh to see if the reply came, you are freezing the decision. Every time you monitor how your body feels after the doctor's appointment, you are stabilizing the fear signal in the orbital frontal cortex. Your attention is doing something measurable to the system you're observing. The question is what to do about it. This protocol is built on 2 verified published sources. The anti-Zeno mechanism from Kofman and Kurizki's 2000 paper in Nature, and Jeffrey Schwartz's refocus step from his PET-validated research at UCLA, documented in BrainLock. 3 steps, about 90 seconds. Step 1. Name the watched pot. Before you can stop watching something obsessively, you need to know precisely what you're watching, not a category, a specific thing, not my finances, but my checking account balance, not my health, but this specific symptom I've been monitoring for 6 days. Write it down. The act of naming it precisely externalizes the object of observation. That is the first step toward withdrawing measurement from it. Step 2, relabel and redirect. Say, aloud or internally, my attention is locking this state in place. The watching is the freezing. Then redirect to something physically present right now, a sound in the room, the surface under your hand, the temperature of the air. You are not suppressing the thought. You are deliberately redirecting the measurement to something outside the watched system. This is exactly what Schwartz's refocus step produces on PET scans. The worry circuit cools when attentional contact is broken. Step 3. Set a release window. Choose a specific period during which you commit to not checking on the watched condition. 24 hours is a reasonable start. Write the window down. Writing externalizes the commitment, which removes the internal pressure to monitor. At the end of the window, take one brief, deliberate look, then reset the window. You are not ignoring the problem. You are not in denial. You are deliberately reducing measurement frequency to allow state transition. This is what the Gita called performing your duty without attachment to the fruits, what Eckhart called Gelassenheit, what Laozi called Wu Wei, and what 2 physicists at the Weizmann Institute documented in a physics lab in the year 2000. The watched pot never boils. Stop watching.